So yeah, welcome to the workshop for Building on Bitcoin Core, PlebLab edition. So basically, before we get started, go ahead and navigate to this link, BOB, which stands for Building on Bitcoin. That way you all can follow along with me. This will link to a PDF file with all the slides. You can also put BBC, and that will take you to the GitHub where this is hosted. And that's cool because I learned this today. GitHub actually has a built-in PDF viewer. So for whatever reason you can't view PDF files, just change this BOB to BBC, and you'll be able to see the GitHub version. Yeah. If you hear honking in the background, that is it's the parade that they're having for me. For dead people. Oh, is that what it's for? Oh, the parade just started. Okay. Anyways, shout out to all the dead homies. Anyway, so back to the presentation. Does everybody have this presentation pulled up? Because there's a lot of links that I have embedded in the presentation, and insert link here. Yeah. No, this is just for you to get to the presentation. Once you download the presentation, all the links will be available. Yeah. So this is the install guide slide. So what we're going to do is we're going to download Bitcoin Core at that link there. And that link should be clickable for everybody. And then these are the three guides that they have available. So they have Windows instructions for Windows, Mac instructions, and the Linux guide. So for Windows and Linux, it should be you simply install the application, you get an icon, you double click the icon, application starts, and then you're good to go. For the Linux guide, you may get an icon, you may not. If you don't get an icon, then just wherever you download Bitcoin Core, find it with your terminal, open up a terminal, and then just use the term Bitcoin QT. You just launch the Bitcoin QT binary, and then you'll be good to go. Yeah, show of hands on who is good to go. Yeah, don't worry if you're syncing to the blockchain. We're going to switch networks pretty soon. So if you get to this section here, let me know when you're ready to basically go over these instructions here. So these are the instructions for opening the config file through the interface. Also, I went ahead and I put what is like the default location for the config file for Bitcoin. In case you can't access the GUI, you want to do this through command line, then these are the locations of the config file for each of the different platforms. So what we need to do for this workshop is we essentially need to get to this point where everybody has their config file open and ready to go, because we have to make some changes to the config file. If you like your config file, you can keep it. Yeah. Is it empty? Oh. Yeah, I think you're good. So who's ready to move forward? Who has their config file open and ready to go? You ready? Okay. Yeah. So this is the interactive part of the workshop. If you can't get to this part where you have your Bitcoin Qt application open and the config file open, then let me know and I'll walk around and I'll help you through it. But we all essentially need to get to this step. This is the big step. Once we get past this step, it's smooth sailing from here. Now, if you are able to get your config file open, the next slide pretty much goes over what you need to put in that config file. And we're going to do regtest equals 1. That will configure Bitcoin Core to launch on the regtest network, which will allow us to essentially have our own blockchain that we can control. We also need server equals 1. That will allow us to be able to send RPC calls. RPC stands for Remote Procedure Call. It's essentially commands that you can send to Bitcoin Core to make it do stuff. But in order for Bitcoin Core to listen for those commands, you have to have server equals 1. And then TX index equals 1 is really useful. Basically, by default, Bitcoin Core will only index transactions related to your wallet, which can be troublesome if you're doing transactions to a smart contract, because your wallet might not recognize that you're in a smart contract, and so you won't be able to look up the transaction. But if you have TX index equals 1, then your Bitcoin Core node will index all transactions on the blockchain, even ones that you're not directly enrolled in with your wallet. The reason why I put maybe is some people have had trouble with this setting, where they would set TX index equals 1, and then their computer would crash or Bitcoin would refuse to run. So if you, for whatever reason, your computer does not like running with TX index equals 1, then you can disable it. It's not entirely necessary, but it is nice to have. Yeah, I'm competing with the parade here that's going on next door. All right, so who is at this step where they have their Bitcoin Core set up, they have this configuration file open, and they put this in their configuration file? Okay, so if you can't launch Qt and you can't generate this config file, you can create it manually. So depending on whether you're Windows, OS X, or Linux, then just go ahead and create this file. And this should be the default, this path here. And just replace brackets U with your username. The reason why I like to do it with the GUI, Bitcoin Qt, is that Bitcoin Qt has a button that you click. It opens the config file. And so, every computer is different. Every platform is different. Sometimes, for whatever reason, your computer will open or save application data in some weird esoteric place on your hard drive. Who knows where? And so the cool thing about opening the config file through the GUI is that wherever that file may be, the GUI will find it for you. It's sort of like the canonical reference of where does this config file live. But by default, it should live in these locations here. So you can just go ahead and create it and then just put this content in it. So once you've put this in your config file, you can go ahead and save it and then restart Bitcoin Core. And when you restart Bitcoin Core, things should look a little different. So instead of having an orange background, you should look slightly different. It should sort of look like this. It's not going to look exactly like this, but let me switch to a wallet that's empty. Yeah. So this is what it should look like. This application here. Can I make it full screen? I can. So the first screen that you come across, if it's just telling you you're out of sync with the blockchain or whatever, you can just hide that message. Yeah. Basically, Bitcoin Core, if it sees that there's no blocks, it freaks out and it thinks like, oh, you're not synchronized with the chain. What Bitcoin Core does not understand is that you're about to start your own blockchain. So you can just ignore the warning that it gives you. All right, so do we all have Bitcoin Core Qt ready to open, or at least we're on the command line with the CLI? So once we get to this section, you want to go to File, Create Wallet once you're in the interface. Avoid spaces or uppercase when you label your wallet, and I will get into why that is. And you do want to, for now, uncheck Use Descriptor Wallet. Yeah. Descriptor wallets are really cool. However, when you have a descriptor wallet, it's not so easy to extract the private key for key pairs because you're using a deterministic wallet. And that is sort of, it's a hindrance in development, because if you want to be able to generate key pairs and dump the private key really easily for development purposes, then this will get in your way. Descriptor wallet will get in your way. But for production use, descriptor wallets are really cool. So on the command line, you will run, in one terminal window, you will run Bitcoin D. And you want to read the output to make sure that it's launching on the reg test network. It is? Okay, so then that's cool. That means it sees your config file, which is great. So then in a new terminal window, you want to open up Bitcoin CLI. And we'll go to this step. So once you create your wallet, and I'll go back to how to create a wallet on the command line. But this is actually relevant for you before you create a wallet if you're doing this on the command line. You essentially want to make sure you're connected to your Bitcoin Core node. So in the graphical interface, you would go to Window at the top, and then you would go to Console, and that'll open your RPC console. If you already created a wallet, then in the graphical interface, you can actually select your wallet from a dropdown, the one that you've created. And then in the bottom, you're going to put in this command, get blockchain info, and then hit enter. If you're doing this from the command line, then you can skip the wallet step for now and just put in get blockchain info, because what you want to do is you want to make sure that your command line interface is connecting to your core node. So you should get a response back when you do this. So show of hands, who has put this in and received a valid response? You got your info data. Austin, you got info data. Darren, you doing good? So if you're doing this through the GUI, it's Window Console at the top. Window, then Console. And then select your wallet. It should be there. There should be a drop down. Here, I'll show you what mine looks like, because I have multiple wallets. So console, and my console's right here. So do you see this? Do you see this drop down here? Okay, if you only have one wallet, maybe this doesn't show up. But yeah, if you create multiple wallets for whatever reason, there should be a drop down here that allows you to select which wallet that you want to use. The reason why this is important is because some RPC commands they're done within the context of a wallet, especially if you're doing wallet-related stuff. So Bitcoin Core needs to know what wallet you're interested in when you run certain commands. Okay, so correction, this dropdown only shows up if you have multiple wallets. And I always have multiple wallets, so I've always seen it there. So yeah, so you should be able to get blockchain info, and you should be able to see something like this. Yeah. Well, you need to have a wallet in order to do wallet-related activities, which on Bitcoin is a lot. So you do need to have a wallet ready to go. If you're doing this on the command line, you just want to make sure in Bitcoin CLI you're able to type in get blockchain info and at least show that you're connected to the blockchain. Absolutely. Well, yeah. Yeah, you need to put it somewhere. Yeah, so I'll go over how to create the wallet on the command line, but when you put in get blockchain info on the command line, do you see this? It doesn't have to look like this exactly, but you see a response of what your blockchain looks like, correct? Okay, that means you're connected. So get blockchain info, this is just kind of like the go-to command to make sure that you're connected to your Bitcoin Core node, because whether you're doing this on the command line or you're doing it in the graphical interface, I mean, the graphical interface, it kind of doesn't really matter as much, but get blockchain info is sort of the way that you make sure that you are connecting to your node. So Bitcoin CLI, you don't necessarily have to use it on the same machine as Bitcoin Core. You can actually use Bitcoin CLI over Tor on another machine somewhere and still connect. So it's sort of like an RPC terminal to connect to your Bitcoin Core node. So, and this is kind of like the hello world. This is just to make sure it's working. So, okay, so if you got this, then you're good. If you haven't created a wallet because you're doing this in the command line, then there is a way to create a wallet, and I believe it's create wallet. Yeah. So one cool thing about RPC commands on the terminal is that if you put the command in incorrectly, as in you don't supply the correct arguments, you'll essentially get this helpful message here that basically tells you what it's looking for. So on the command line, the RPC command to create a wallet is just simply create wallet. And so if you type that in and hit enter, you will get this message basically telling you, hey, this is how you use this command. So you would simply do create wallet and then the wallet name. And that's how you would create a wallet. So the question is, what is a wallet and what is the wallet? How does the wallet, how is it related to a node? So your Bitcoin Core node is essentially what is plugged into the network. So Bitcoin is a network of relays, and your node is just one of those relays. Bitcoin essentially is a protocol that all of these relays use to talk to each other and forward traffic. So your node is receiving transaction data and block data from other nodes that it's peered to. It's validating this data and it's sending it forward. So that's what Bitcoin Core does. Plugs you into the network, you get this stream of data, and you're just relaying that data. You're participating in the network. Now, if you actually want to use that network, you actually want to move money around, that's where the wallet comes in. So what a wallet is, essentially, is it's a key ring. So you have a set of keys We call them key pairs. A key pair is usually a private key, and then there's a public key. The private key you keep private, the public key you keep public. So what your wallet does is your wallet organizes and stores all of these key pairs for you. And as this data stream is coming through to your node, all these transactions are flowing through, all these blocks are flowing through. What your wallet does is a filter. So it's like, hey, these key pairs, I'm interested in these key pairs. So, analyze all the data that's coming through. And if you see this key in a transaction or you see this key somewhere in a block, I'm going to let you know about it because this is a key that pertains to you. And so that's essentially what a wallet is. It manages your keys and it keeps a lookout for if these keys show up anywhere on the blockchain. We call it a wallet because financially that's kind of what makes sense to people, but it really is like a key management thing. So yeah, so when you create a wallet, you're essentially creating a folder where all of these keys are going to be stored. So are we all at this point? We all have a wallet created and we're ready to go? Okay, so we've done this part. And okay, mining blocks. This is the fun part. So this is how you get rich quick on Bitcoin. You type in this in your console, get new address. And if you do this without a wallet set up, then Bitcoin will get mad at you because this is one of those commands that you sort of need to, your Bitcoin needs to have a wallet available because what this does is it generates a new key pair for your wallet. So if you have no wallet, then this command is useless. But this get new address should generate a new address for you that it will then store in your wallet. And you're going to copy that address that it gives you. So start with BC1. Or no, actually start with BCR for edge test. Yeah. So this is the next command we're going to do. Generate to address 100, and then put your address afterwards. And what this will do is this will automatically mine 100 blocks on your new blockchain. And it will deposit all of the money that you get, because you do get money from this. You get the Coinbase reward for finding all of these blocks. And it'll deposit it into this address. So I'm going to I'll demonstrate that real quick. I already have plenty of money on here, but I'll go ahead and go through this. So get new address. There's my new address. Copy that. And then generate to address 100. And then boop, boom. And boom. So what you'll see is an array of 100 different hashes. And all of these hashes are essentially the hash of the block. Now, if you were looking at this on the Bitcoin mainnet, you would see a whole lot of zeros preceding these hash numbers, because those zeros essentially what equate to the difficulty target for mining on Bitcoin. But in reg test, there is no difficulty. So it doesn't even matter. You just get a bunch of random hashes. No difficulty is applied.
So I just did this, but then I did get wallet info, and it's showing me my balance is 0.
Right. So on Bitcoin, when you mine a block and you get the reward, your reward is actually locked in escrow for 100 blocks. So what you will see in your wallet is that you have funds that are incoming to you, but those funds have not yet matured. So once you generate to address, 100 address, you probably want to mine one more block. So we'll just do generate to address 1. So we'll mine one more additional block. And this one block will release the escrow on your first set of funds from the first block that you mined. So yeah, it takes 100 blocks for your Coinbase reward to mature for each block. This wallet has no available keys. Is anyone else getting that error? Yeah, try creating a new wallet and see if you can select that wallet. Right, so in order for transactions on the Bitcoin network to be finalized, they need to go into a block. And that block needs to be accepted by the network. So when you're doing development on Bitcoin Core, let's say you put together a transaction. And we can do that right now, actually. That is the next slide. So I'll explain this concept while we're going over this side here to send a payment. So this will demonstrate why you need to mine blocks. So let's go ahead and try and send a payment. So you have a bunch of money. If you go to your actual wallet and you select the send tab, you could put an address here into this pay to field. Now, it's very easy to pay yourself in Bitcoin. All you have to do is generate a new address, put that address here, put an amount. You could put any amount in there. Set the custom fee since we're on reg test, so there's no way to determine what the fee rate is for our own private blockchain. So you just set a custom fee. And the minimum is 1,000 Satoshis. I think that's the minimum relay fee. Or no, actually the minimum relay fee is lower than that, but for whatever reason, I just put 1,000. So, and then you can click send. Yeah. So when you send this payment, you don't have any Bitcoins? You have to mine one more block. I went over it earlier. No. Yeah, so if you don't have any funds, just mine one more block and you'll have funds in your wallet. So I'm going to skip forward really quick to this. So this link here in the final slide, standard RPC API documentation, that will list all the RPC commands that are available. And the one that you are interested in, we'll actually go ahead and pull that one up right now real quick. Because I have it pulled up here, I think. No. Wait, here it is. Yeah. So this is like my Bible, this RCP API reference, and this is linked in the final slide. So if you're doing this through the command line, this is super useful. Because in Bitcoin Qt, the console has autocomplete, so you can kind of like figure out what the commands are. But in CLI, you don't have that. So yeah, so here you'll have like get balance, get balances, get address info, all this fun stuff. You would also use this to send money. I think it's just send or send to address. Yeah. So if you want to send money through the CLI, then send to address is your friend. Send to address will do that for you. But so to get back to sending a payment, so when we send this payment, whether you do this through the GUI or you do this through the command line, when you send this payment will not show up in your wallet as being paid. So when you send a payment, this transaction will go out and it will go into this thing called the mempool, which is essentially kind of where all Bitcoin nodes stash transactions that they come across. They forward transactions along in the network, but they also keep a local copy for themselves. So this local store of transactions is called the mempool. But the mempool is not the blockchain. So when you send a transaction, it will sort of go out into the network and all of these nodes will save it to their mempool, but that does not mean that your transaction's been committed. So your transaction, in order for it to be official, for it to actually settle and the amounts to be true, it has to go into a block, and then that block has to be accepted by the network. So that's where mining comes in. So when you send this payment, it will not be reflected as being complete in your wallet until you mine a block. You have to mine a block in order for your transaction to be valid. So no, those blocks are essentially empty. So anytime you mine a block on Bitcoin Core in reg test mode, whenever you mine a block, what happens behind the scenes is that any transactions that you have in your local mempool, they automatically get put into that block. So the block is really just like a container that you can stuff transactions into and then commit that to the blockchain. So it's only whatever transactions you have in your mempool that gets stuffed into a block. Right. So they're just empty blocks. And if you look them up, you can see that they're empty. If you were to go to your console, and you can actually look these up, like you can, let's just take this random block, for example. Because you need money. It's essentially, yeah. So this is one of the blocks that we mined, and essentially, there's one transaction in here, and this one transaction is the Coinbase. So if we go to get transaction, we look at this. So category immature, meaning that from the perspective of this transaction, it has not been 100 blocks. 100 blocks have not passed. So this reward has not been paid out just yet. But yeah, so this block is essentially an empty block. It only has one transaction, and that transaction is the Coinbase. But we can change that, and just to kind of show what that looks like, we're going to go ahead and send some money. So let me create a new address here. Take this address. And you can, in the command line, you can just put get new address to get a new address. And then, in fact, let me do this through the console, just so if you're using the command line, you can follow along. So send to address. We need to specify, what's this? Send to address and amount. Easy enough. Is that amount in Bitcoin or Satoshis? I forget. Yeah. So anytime you do get new address, it just gives you a random address. In Bitcoin, you want to use random addresses because you don't want to have any deterministic links between where your money's going for privacy reasons. So it's just good to, it's like a good security practice. Just always use random addresses for everything. So yeah, so send to address, and we're going to send to this address, and oops. And then we're going to send 1,000 sats. Well, 10,000. Is this Bitcoin or sats? Let's find out. Oh, so I forgot to mention that you have to set your fees in the command line if you're using the command line. Set TX fee. So yeah, if you're doing the command line, you do have to do this additional step, which is you have to set the transaction fee amount. So let's do that real quick. Set TX fee 1,000. Okay, so it is in Bitcoin. So it has to be 0.00000. So 1 Bitcoin is 100 million Satoshis. So let's do it this way. It's 100 million Satoshis. And that's where they put the decimal point. We want 1,000 Satoshis. Yeah, I don't know why Bitcoin Core does like BTC by default and not Satoshis, but there we go. So set TX fee 0.00001. That's set. So now, if you're doing this from the command line, huh? Yeah. Set TX fee 0.00001. So that will be 1,000 Satoshis. And now we should be able to send a transaction. Insufficient funds because Bitcoin Core likes to do things in BTC instead of Satoshis, which annoys me. So 1 is 1 BTC. Send that, and boom. So now this is sent. So we just sent money. And what we get in response is this transaction ID. And we can look it up. Get transaction. Oops. Get transaction. Not the raw transaction. Oh, yeah, we'll do the raw transaction. So that's the raw transaction. It's kind of indecipherable unless you know how to read a raw Bitcoin transaction. So we'll just do get transaction instead. Look this up. And this is a transaction that we sent. So you can see that we're sending 1 Bitcoin from this output. And we're sending it to this guy, which is this address. But what's that? Oh, yeah. So get transaction is Bitcoin's own way of displaying like some information to you. It's not the actual structure of the transaction itself. So it's just kind of like a summary. And so the summary is basically saying that you sent money from this address, this UTXO, and it's going to this place, this new UTXO. So that's what this is telling you. So it's an overview. But you can do a neat little trick where you say get transaction, the transaction ID, and you can say false, and then you can say true. And it will actually decode the transaction itself for you, and then you can see the full transaction. So you can see the input, you can see the witness, sequence, transaction ID, all the fun stuff. You can see your change output. You can see all sorts of crazy things going on. So I had an output with like 75 Bitcoin in it. And so it split that off and sent it to the person that I wanted to send it to. And then I received this as change. So you can see all that fancy stuff by doing this command here. It's get transaction, but you put false true at the end. You can kind of look up if you look up the details of this RPC command, you can see why you have to put that, but that will essentially show you the full transaction. But this transaction is not confirmed, 0 confirmations. So in order for this transaction to actually go through, we need to mine a block. So if we go back through our transaction or our command history here, and we go to generate to address, so you just generate a block, just like that. Boom. And now we have a hash here of our block. And so if we inspect this, get block, and we look inside this block, we'll see there's actually 2 transactions now. There's the one transaction at the top, which is the Coinbase. That's the one that pays out the reward. And then here's our other transaction right here, sitting inside this block. So now if we take a look at this transaction, get transaction, and we look at it again, we can now see the transaction's confirmed as one confirmation. And if you look at this in your wallet, which is easier to do for the GUI, but you can also check this on the command line as well. but you can look at your transaction list and you can see that here we go. That's our payment right here.
What command did you use to like look at the block code?
Oops. So yeah, it's get block and then the hash of the block. Okay. So far we have created our own blockchain, mined a bunch of blocks, mined one extra block to get the funds. So we actually have some funds, sent a payment to an address, and then mined another block to commit that payment to the blockchain. Are we all at this step? We're good? We're here? Let me know now, forever hold your peace. We're going to get into the real fun stuff next. Okay, so if you're at this step, there's one extra step that we have to do before we get into the real fun stuff, and that is this. So the RPC interface on Bitcoin Core is very powerful because it essentially gives you access to all of your money. It is the keys to the castle. So if you're going to be developing stuff and you want to command Bitcoin Core with your own programming language, you're going to want to set up some authentication first. You don't want just anybody to be able to log in and move your money around, because then they will move your money away from you into their wallet, which will be bad. So in order to do this step, there's this really cool website that is linked in the slide. It's called the RPC auth generator. And we're going to use this to generate what is called an RPC auth string. And we're going to add this to our Bitcoin configuration file. And then we're going to restart Bitcoin Qt, or just restart Bitcoin D using the command line. And then that will lead us to the next step. So let's go ahead and do that. So we're going to demonstrate this here. So it will be this here. So this is the Bitcoin Core auth config generator. So you can just do like something for testing, like a throwaway. I usually do username Bitcoin, password Bitcoin, nothing fancy, and then generate. And then what you'll do is you'll get this string here. You can see that. So what it'll do is this is what's going to go in your configuration file. It is essentially your username, the hash of your password, and a salt. And I believe this little $sign is what splits between the salt value and the password, the hashed password. But yeah, so this whole thing is essentially what you're going to use to authenticate. So you just take this whole thing and you go back to Bitcoin Core. No, because the salt is random. So when you're generating passwords for extra security, there's this randomness that's injected into your password. So even if we do have the same password, the string will be different each and every time. So we take this string, and now we're going to go into our config file, like that. And here's my config file. Oh, it's way too big. Let me shrink this down. So as you can see, I have a few extra things in my config file, but this is how I add my RPC auth. Is that correct? Or is that just showing weird on my screen? Yeah, RPC auth equals Bitcoin. The equal sign looks distorted for some reason on the projector screen, but that's an equal sign. So it's just basically you copy paste this into your yeah, you know, I don't really use this notepad, so I honestly don't know how to use it at all. Like, how do you even? Oh, okay, let's give it a shot. Yeah, because I don't think that works on this. Yeah, Control+ doesn't work on this. There's probably some other way to do it. Yeah, this is like a very basic editor. Yeah, it's not going to be under view. There we go. You can change the font. Monospace. Oh, good old monospace. Good old monospace. And then we'll do 14, 16. Go 16. Whoa, yeah. That's what I'm talking about. No, you do not. You do need this for other RPC config options, but you don't need it for the RPC auth. So yeah, so you just want to put this RPC auth string in your config file and then restart Bitcoin Core, and then you should be good. And then once we do that, now we can move on to the really fun step, and that is making RPC calls to Bitcoin Core without the interface and without the command line. So once you go through this step, you generate an RPC auth string, you add it to your config file, restart Bitcoin Core or Bitcoin Qt or Bitcoin D. And yeah, now we get to go to this step. In your config file, your Bitcoin Core config file. You can put it anywhere you like. Yeah. Put it anywhere you like. So this is an RPC request. It is pretty much a basic HTTP request. Show of hands, who's familiar with doing HTTP requests using like fetch or what's it, requests from Python? Or, yeah. So this is how you do a request to Bitcoin Core. You can do it in JavaScript too. Yeah. Just a note is Bitcoin Core does not add CORS headers to its responses. So if you try to do this from the browser, it will fail. And this is a hot debate in Bitcoin Core, adding CORS headers. And a lot of people don't want it, so it hasn't been done, which is fine. But if you don't have to worry about CORS headers, so if you're doing this request from Node or you're doing this request from a server or anything, or you just can get to ignore CORS headers aren't checked, then you don't have to worry about it. But yeah, so this is what the request looks like. So essentially, we're sending it to our Bitcoin Core node. Since we're hosting it locally, we're just using 127.0.0.1. There's no place like home. And this port number is the default port number for RPC calls on RegTest. This port number will change depending on what network you're running. If you're running mainnet, this port will be different. If you're running testnet, this port will be different. Signet, this port will be different. So each network that you can run Bitcoin Core under is going to have a different port. And you can specify this port manually in your config. Yeah, RegTest, you can actually peer on RegTest. So you could have a RegTest network that is global. But the thing with RegTest is that there's no proof of work. And there's essentially nothing stopping anybody from mining a block on that network. So you wouldn't want it to be a global network because it could get griefed pretty easily. And that's why we also have Signet. Signet allows you to put restrictions on who can mine blocks. On RegTest, there's no restrictions. There's no proof of work. You can mine blocks immediately. Anybody can mine a block. So for a local development, that's fine. For like developing across, you know, like different groups that are across the world, it could get griefed if it's open to the public. RegTest is your network. Yeah, it's your network. It's its own blockchain. So you're creating a blockchain from scratch. Yeah. If other people connect to you and they essentially are synchronized to your blockchain, then you're all on that blockchain. If you all agree to that blockchain, you're all on that blockchain. Well, right now we don't have any peers, so we're a very lonely blockchain. But all of the peering in RegTest works just like mainnet. All of the transmitting of blocks and transactions and relaying, all of that works just like mainnet. Like everything else underneath the hood works just the same as mainnet. So you can run two RegTest nodes and peer them together, and then blocks mined on one node will appear in the other. Yes. Exactly. Yes. Super, you had a question. Yes. Yes. So when you peer, your node will ask the node that it peers with, hey, do you have any blocks that I am not aware of? And then my node, let's say I'm the peer, will respond and say, oh, yes, I do have blocks. And then I will give you my blocks. And then you will sync to the chain that I have. And nobody. So the only way that you're able to peer and sync to my blockchain is if you don't have a blockchain. If you do have a blockchain, then you will see my chain as being invalid. So the source of truth is always you, your node. Your node is always the source of truth. You peer with me and you see like, hey, I have this whole blockchain too, but my Genesis block is different than yours. I have a completely different, I started from a different point. You'll just tell me like, oh, well, that's not a valid blockchain. So the only way like for you to download my blockchain is if like you see me as the source of truth. And the only way you can see me as the source of truth is if you don't have any blocks, essentially. So yeah. So if you, and you can run into problems when you're doing like heavy RegTest development where you're generating blocks on two different nodes and they actually go out of sync with each other. And they fork, essentially. And so the only way to resolve that is to delete the blockchain on one of them and then resync with the other. It's the only way to fix it.
Besides the fact that we're starting a new blockchain for Genesis, are we out of consensus in any other way, which is like Bitcoin network? Or is it only the fact that we're starting Genesis? But like there are different rules.
Yeah, so there are things that are slightly different. So for starters, there's no proof of work on the RegTest. So just by that alone, it's invalid. The Genesis block has a very specific hash. And so that sort of determines like what your source of truth is that Genesis block. So that's also different. So then that invalidates. That's what separates your RegTest blockchain from any other blockchain, including other RegTest blockchains. What separates you from other networks is that the addresses are different. So when addresses are generated, there's these little bits that are inserted into the address that basically determine like what network it's from. And that's just so like wallets kind of can also understand like what network an address is supposed to be a part of, which is really useful in development. Like for example, Zeus wallet will recognize RegTest addresses. And so it will know that you're on RegTest, which is great because then you can use Zeus for RegTest development. You can use Zeus for your mainnet stuff. Like you can just like use it on different networks. So yeah, so there's like little things that change in the software configuration wise that sort of like signal like, hey, this came from a RegTest network, this came from a testnet network, this came from a mainnet network. So yeah.
So like Regtest has the most consensus changes and kind of trade-offs just to make it easy to spawn up locally develop on, right?
The only real difference is that there's no proof of work. Everything else is just formatting differences, but there's not actual differences to the underlying code. Yeah.
What's the differences in testing? Is it just like faster blocks?
The differences in testnet, there isn't really any differences in testnet if you're comparing it to mainnet. Yeah, it's just formatting differences. Like the addresses have a slightly different format, but they're essentially the same. Oh yeah, you're right. It does, because there's like, if like a certain number of blocks or blocks haven't been mined after a certain amount of time, like the proof of work resets to 0 or the target resets to 0. Yeah. So yeah, so it's like the consensus rules are a little different for testnet.
That's just very cool. Just a way to keep it going, even though there's no incentive.
Yeah. 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 So yeah, so the biggest difference, and sort of like the only real fundamental difference between these different networks, is the consensus for how blocks are accepted. So mainnet, we're all aware of the proof of work for mainnet. For testnet, there's some little quirks added to it to keep the blockchain going. For signet, there's no proof of work, but you do have to sign blocks, and so you sort of like set up like who is allowed to sign. And then Regtest, there's nothing. There's no proof of work. There's no signatures. There's no nothing. It's like anybody can mine a block.
Would Signet be similar to like the Liquid network, where it's like functionaries?
Yeah, so you could essentially create your own Liquid network with Signet. So what you would do is you would just set it up. So when you set up a Signet network, you basically, what you do is there's this special configuration option that you put in your Bitcoin comp file, and it's called the Signet challenge. And what the Signet challenge is it's essentially like, it's a little Bitcoin script. And so that Bitcoin script is what's used to validate the blocks. So you can make that Bitcoin script a K of N multisig. And if you do that, then essentially you've set up a Liquid network. Because anybody that wants to join your network will have to have this, they essentially have to agree to this script. Like, this is the script that validates blocks. And so that script will be similar to a multisig, where it's like, well, the pub key hashes are inside this script. They lock certain key pairs to this script where only certain key pairs can sign. And so if everybody agrees to this script, then you essentially are agreeing to, like, these are the only people that can sign a block. And you can also agree to like a consortium. So it has to be like 2 of 3 or 5 of 10 or whatever. So yeah.
How do you then add additional functionaries or signers or whatever?
So I don't know if you can change, like so you can start a Signet and you start with this challenge, because this Signet challenge, the script that kind of sets up who can sign, it's also baked into the block, the Genesis block. So I don't think you can change it once you've started the blockchain for that, for that Signet. So once you start it, you can't change it. But when you first start it, essentially that script is what defines the Genesis block for that chain. And so then anybody else that wants to join your Signet, they have to put that script in their config file to basically say, hey, like, this is the script that I'm agreeing to. I will basically see any block that matches the script and validates against the script is a valid block. So you're using this like script to validate blocks instead of proof of work, essentially. And that script could be anything. Like it most practically is like some sort of multisig, but it could essentially be anything really that you use to validate blocks. So it's kind of cool. You can validate blocks based on a Bitcoin script instead of just proof of work. So yeah, you could do Liquid, you can do all sorts of stuff. But yeah, so back to Regtest. This is what an RPC request looks like for HTTP. So we're running a local node, so we go here. We have 18443 as the port. That's the Regtest port. That is configurable in your Bitcoin config. And then It's helpful to also specify the wallet that you're using because a lot of RPC commands are wallet related. So if you want to specify a wallet for your command, you just put wallet /wallet / and then the name of your wallet. And this is why it's helpful to have a lowercase, no space wallet or like underscores or whatever. You sort of treat it like a variable in a program script. Like you want it to be easy to reference. You don't want any foot guns or gotchas in the name, so it's just nice to have like a simple name. You're doing a post request. Your headers, this is essentially your authorization header. You have this prefix basic, space, and then what you're going to have is a base64 encoded string. And this base64 encoded string is just your username and your password. This is the username and password that you put in to generate the RPC auth string. So when you generate that RPC auth string, that string goes into your config file. The username and password, however, this is what you specify. So you take the username, you take the password, you concatenate them with a colon, you base64 encode that whole thing, and that becomes your API key, essentially. It's your API key for doing the call. And then in the body, you have to stringify the body. So JSON stringify or JSON parse or dumps. JSON dumps, is that the Python one? So you have to send your body response or your body request as a string, but it's essentially this JSON object. So this is called JSON RPC. And they have a JSON RPC 2.0 now, so you can do 2.0. But 1.0 is pretty simple. And you just put the version number. We're doing 1.0 right here. You could put a random ID here. It's just a random string that is sent back to you with the response. So if you want to be able to match a response to a request, if you're doing stuff asynchronously and you're not sure what response matches what request, that's what this ID field is for. You can leave it blank. You can make it random. You can do whatever you want with it. It's just passed back to you with the response. These final two parts are the important ones. So the method name, that is essentially the name of the call. So get new address, generate to address, get transaction, all those RPC commands that we've been using, that goes here. And then params is an array of the arguments that you're passing to the method name. So if we were doing generate to address, there'd be two arguments, the number of blocks and the address that you're sending the Coinbase reward to. So then it would just be generate to address 1 for 1 block and then your address. And so that is a HTTP request to your Bitcoin Core node right there. And so if you know how to do HTTP requests and you have your Bitcoin Core node running and you have a wallet and you have a username and password, you can now control it using HTTP requests, which is super useful. Yes? You never seen this before? Oh. Well, I mean, this is how fetch works. Never use fetch. It's like the most ubiquitous way of doing requests. Right. Yeah, so the second field in fetch, you can specify an object. And this is what you would specify. You can also, I don't know if this is the correct key, but you can also specify the URL. So you don't even need to pass a URL with fetch. You can just specify it in the request. It's part of the spec. But yeah, we can get into that. So we can get into all the different ways that you can do RPC requests. So RPC stands for Remote Procedure Call. There we go. So this is a link that I will show you later because I have a big resource of links in the presentation. But this kind of goes over how to do different RPC requests using JSON RPC, which is just using HTTP requests. And so yeah, so this is how you would do it in Python. This is how you would do it in Ruby. Never really got into Ruby too much. Erlang, PHP, Java, Perl, Go, .NET, Node.js, excuse me. All sorts of languages. Oh, curl. This is how you can do it in curl. It's kind of cool. So if you're familiar with curl, I don't even know if they have curl on Windows. I guess Windows Services for Linux has it. Does Mac OS X, do they have curl? They do? Okay. So this is how you can do it with curl. User is user. Data, binary, JSON. This is like the sort of the body that you're sending. Content type, text plain. So this is how you would do it with curl. You just sort of like replace certain things. Like this 8332 you would replace with your the port for your reg test. Yeah, I don't see where you put the password though. So I think in curl you can specify a password as well. But if for whatever reason, if this doesn't work, the reason why I wanted to show you this slide is this is the canonical way to do it. So if you ever get stuck with your programming language on how to do a request, just know that whatever your language is outputting when you're doing the request, it needs to look like this. Like this is the format. It's basic, space, base64 encoded, string of user and pass concatenated with colon. That's your API key. So as long as you're able to send a request with this format in the body, post request with this format in the header for the authorization, and this sort of URL scheme, then it will go through. It will go through. So that is the format. And I have more resources in the final slide here. So we went over the RPC API documentation. We went over Bitcoin Core. Oh, we didn't go over this. Bitcoin Core config generator. Programming Bitcoin by Jimmy Song. Really awesome resource. And I also have the GitHub here that has a whole bunch of links in it, including the link to this page showing you how to do API calls for different languages. And I also have some boilerplate for how to do like a very basic RPC library. I think I had it pulled up here somewhere. Yeah. So that is, this is in Python, right? So this is an example of doing, essentially creating a library for doing these requests in Python. So you can see that Python kind of hides a couple things from you. Like when you do the actual request, let's see, where is that field where you do the actual call? Self method args, init flag. There's, yes, oh, here it is. If the connection is refused, then you have to make sure that your Bitcoin Core node is opening that port. So it should be open by default unless you have something extra in your config file that has changed it. But when you start Bitcoin Core, here, let's actually start Bitcoin D. So when you start Bitcoin D, you get nothing because I'm running it as daemon. Hold on. So I want to kill all Bitcoin D. Oh, poor Bitcoin. Oh, okay. Yeah, curl does do that. It'll ask you to put in the password interactively. So really quick, I just want to demonstrate something. So what we're going to do is we're going to hop into our Bitcoin .config file real quick. Yeah, it should be Bitcoin.
Sorry, what library does the 2base64 method come from?
So base64, I want to say it's essentially the same as base58. It's just a full 64 character library, and base58 doesn't have a
I
checksum.
know what base64 is, but like what library are you getting this method from? I just copied your like request object and I'm trying to run it in Node.js.
Oh, okay. So in Node.js, you want to use the buffer object. So really quick, I'm just setting my daemon to 0 so I can see the output of running Bitcoin Core. But yeah, just real quick, if you can see this, Austin, it's like buffer from string goes here, and then you'll say like to string. It's kind of weird. You're going from a string to a string, but you would do string and then you would do base 64 like that. So that's how you do it in Node.js. In the browser, they have these functions called A to B and B to A. So in the browser, they have a native way of doing base64 encodings. But yeah, every programming language is different. They'll have their own library for doing base64. You can also implement your own. It's actually pretty simple. It's a pretty simple algorithm. But yeah, so if I start Bitcoin D, basically I get all this stuff. And I can see that it's binding to ports. So I can kind of see what ports are being bound by Bitcoin D when it starts. So if you have any issues connecting to your Bitcoin Core node, this is a good way to debug it. Just run Bitcoin D. Make sure if you have daemon set that you disable it. You want daemon to be 0, otherwise you won't see this stuff. Another thing you could do is you could look at the logs, but it's just easier to kind of see this in real time. And so yeah, so you can kind of look and you can just make sure that everything is being bound properly. So if you have any network issues, then port. This is the private peering port. I don't actually see where it's binding my reg test port, but I know it's in here somewhere. Just can't find it. But yeah, so running Bitcoin D like this kind of lets you know like what's going on behind the scenes. Also, wherever your bitcoin.conf file is, so like let's kind of look at where my bitcoin.conf file is. You will also, man, how do I blow this up? Make this bigger so you all can see this. Can I just make this bigger like this? No, wait. I know there's a way to do this. Is it this? Yeah. Make it bigger. There we go. So let me clear the screen. So you can see in my, okay, CD Bitcoin. So I'm inside my Bitcoin configuration directory. This is where my bitcoin.conf file is. So you'll kind of see something similar. Anytime you start a new blockchain, you will see a new folder storing that data inside your main Bitcoin configuration folder. So if I go into regtest, this is where my blockchain lives. So here are my blocks, indexes, the chain state, all my UTXOs are in there. The mempool, there's the data file for the mempool. Wallets, any wallets that I've created, my wallets are in there. All of these like helpful little things are in here. The ban list. Ban list is an interesting one. But yeah, so debug.log. So you can always just do something like tail, debug log. And you can see this too. So this is essentially like the same as what is showing on Bitcoin D when you start it. Same stuff. That is only showing me the last 10 lines. If I were to cat this, oh, this might be a bad idea. Oh, there we go. So this is another way you can sort of like debug your Bitcoin Core if you're running into issues, is you can look for that debug log. And the debug log is stored within the folder for the blockchain or for the network that you're using inside your Bitcoin configuration folder. Okay. So examples on how to do RPC calls. So I have a little library. So this is linked in the final slide, this Bitcoin programming. And in the examples, I have some examples for Node.js and I have some examples for Python. So this would be an example to how you can do some transactions. So this is a pay to pub key hash right here. And so, yeah, so this is how I can basically create a transaction, send money, move money around, and sign it, do all that stuff, and just do it from within Python. I'm not even touching Bitcoin, Bitcoin Qt or the command line or anything. So I created this like RPC library. That's the one we were looking at earlier. And I made it so that I can just specify what wallet. So I have a wallet called RegTest. And I am essentially specifying that, okay, I want to make RPC, JSON RPC calls using this wallet. And then I just make sure that it's working. This is just running get blockchain info behind the scenes. And now I can do cool things like rpc.getUTXO. And now I can just grab a UTXO. What does that look like? Well, I can show you the manual way of doing it. So the manual way of doing it would be Bitcoin D is not running, right? So I can just do Qt. So that should launch Bitcoin Qt, right? So the manual way of doing it is to go into your console and do, was it list unspent? Yeah, list unspent. Oh man, I have a lot. So yeah, so list unspent is a command that gives you all of your available UTXOs that you can use to spend in a transaction and all the information related to them. You get it in this huge array, and this is all valid JSON. So, you know, looking at this in the console, it's really not fit for human consumption. This is just way too much to go through. But if you're able to get this response back in a program, then you can easily go through this. So that's some of the cool stuff that you can do. You can essentially write a script that says, hey, just get me a UTXO. And I just put index 0, just say like, get me the first UTXO on the stack. And now that entire UTXO is in this variable. And so now I can do other cool things. I can say get receive, like get a receiving address, and I can even specify the format. You can do things like decode an address, because like there's all these cool things you can do with RPC commands that once you sort of build the bridge between the RPC commands in your program, then you can just essentially do all this cool stuff where you're automating transactions, you're sending money around, you're just doing all this stuff automated. Like I'm building a transaction from scratch. I'm even putting in the opcodes. Like these are the opcodes that actually go into it. This is a pay to pub key hash right here. Opdupe, hash 160, hash equal verified checksig. Yeah, so you can just do all this manually. It's all JSON, so it's all really easy to use. I have a library here that you can use for like encoding and decoding transactions. But if you'd like to build your own library for working with Bitcoin Core, then I would say that the best resource that you can use is the one that is on the final slide. And that is this right here, Programming Bitcoin by Jimmy Song. Really great resource for building your own library. Or you can just use an existing library. There's like a bunch of different libraries out there for connecting to Bitcoin Core. Or you can just do RPC calls through HTTP. And yeah, and so I think that's about it. Yeah, so because everything is essentially the same, it's just that the consensus rules are different, then all of the code that you write will work on any network, essentially. Yeah, so you would, all the code that you write for RegTest, you make sure it all works. Then you can switch to another network. You can switch to testnet, make sure it works there. You would do that in the config file. So in the config file, you can set regtest equals 1. You can set testnet equals 1. And so you can use that to join different networks. And there's this really cool resource called the Bitcoin Core config generator. Yeah, this final slide has some like really great resources on it. So I built this slide to use as a resource in of itself. So this Bitcoin Core config generator, it'll actually walk you through like every single configuration option that's available and the formatting for it. So if you want to configure your Bitcoin Core node, you can do all sorts of crazy configurations. But it's really useful, and to show what that looks like, because it's essentially this. So you can kind of like go over basic, like all of these basic configurations, data storage. You can change the location of the data folder. You can do some database stuff. You can actually chain config files together. So you can actually have like multiple config files and you can import them. So that can be really useful, especially if you're programmatically changing the way that Bitcoin D runs. Then this is very useful because it's an additional way to inject configurations into Bitcoin Core. But yeah, there's all sorts of cool stuff you can do with this core config generator. I don't actually use it to generate my config file. I like doing it manually, but it's just an amazing resource for just seeing like all the options that are available and how you can do different things like chain selection. That's the one we were just talking about. So how do we, if I were to do regtest or signet, or if I want to just change it here, testnet, it'll actually show you here. This is not formatted in the best way. Maybe I have to bring this down. But yeah, so it'll kind of like show you what those config options look like. So here we go. Chain equals test. That's essentially what this option down here means. So better signet integration. Signet is kind of a pain in the ass to use. It's easy to use if you're a user, but if you want to create a signet, it's a kind of a pain in the ass because you have to like do this special thing with how you sign blocks, and it's just like, no, I have to fix the scripts for a signet so I can get a signet up and running so we can have a signet for PlebLab. But yeah, that's like the biggest pain point is like signet is not easy to start up. It's easy to join, it's not easy to start up. So there's that. And yeah, so there is BTCD, which is the Go implementation of Bitcoin that is managed by Lightning Labs. There is Bcoin, which is a JavaScript implementation of Bitcoin Core that you can also use on its own. And there's Bitcoin S, which is a Scala implementation of Bitcoin Core. So ultimately, Bitcoin is the protocol. So as long as you have a piece of software that implements the protocol for nodes talking to one another and for the consensus rules, that's all you really need. So Bitcoin Core is like the reference, it's the standard, but you can create your own core client, your own node if you want, as long as it follows the rules. So yeah, do you want to get into any interactive stuff? Or how long have we been running? Okay. So yeah, I guess I'll open up the floor to questions. Like, do you have any questions on how you would essentially write a program that talks to Bitcoin Core? Any questions on how you would do that? Or does it seem pretty clear?
I guess I'm wondering, is it kind of a similar setup if I'm going to set up like a format and API to communicate with a Lightning node, like an
It's slightly different, depending on the implementation. So LND has an RPC interface. So it's just a matter of, there's two things. It's what are the commands, and what is the authentication. So for LND's RPC interface, it's very similar. You just need the URL and the port for the RPC interface. You need to know the commands and the arguments that you have to send, and the authentication. The authentication is a little different because in Bitcoin Core, we're using this thing called RPC auth, which has its own way of formatting this authentication string. Whereas with LND, they're using macaroons. And so you have to kind of know how to create a macaroon and how to like insert that macaroon into your request so that you can authorize your request. So other than that, it's essentially the same. Core Lightning, I think, is the same, but they really want you to use their manifest and their plugin system. And so they sort of abstract away the RPC interface with this plugin system, which you're going to love it or you're going to hate it. So if you like the whole RPC thing, like making requests to an RPC interface, then you're going to like LND more. It's more straightforward. Yeah.
So Bitcoin Core is the canonical, that's where all the core devs are for Bitcoin. And BTC is like a different implementation. Is C Lightning and LND similar in that way? Like C Lightning is the core where like core Lightning developers are, and then LND is.
I would say yes, except I would swap Core Lightning and LND. I think LND is more of a reference implementation for Lightning than Core Lightning is. Core Lightning, they're doing cool stuff. They're trying to push the protocol forward. But I think when it comes to like who's actually using, like which one's the most popular, LND is the most popular. Mainly because it's very enterprise friendly. And so essentially just a lot of big names adopt it. And so it kind of, they kind of, that weight that they have because of their market share kind of makes them the reference implementation. So yeah, so in Bitcoin, the changes to the spec is like a very grueling process. And so that's pretty much ruled by the core dev team with an iron fist in that community. Lightning, it's a little more loose. There's more competition with spec. So you already have a divergence between LND and Core Lightning, where they're trying to pursue like different ways to push the protocol. And then you also have like other stuff happening on the sidelines, like LNURL, which is like a completely different thing. So yeah, so I was gonna pull up real quick Lightning Labs, GitHub, Lightning Labs. Yeah, I think this is, so any more questions regards to like setting up Bitcoin Core, getting a reg test environment set up, and then how to do like RPC commands to your node through a programming language? Are we good with that? I think we are. Okay, I think that's it. Awesome.